my name is Ethan Kwan and this is Bisham Montgomery High School Math Tutoring Club. We're located on Torrance Boulevard, right next to Redondo Beach. Today we're going to talk about the left and right Riemann sums with the basic tricks to do it. So, what is left and right Riemann sums? It is a method for calculating or estimating the total area underneath the graph. So, I'll graph the given chart. When x equals to 0, y is equal to 2. So graph now looks like this. First, I'm going to graph right Riemann sum. So what does right Riemann sum means actually? So right Riemann sum means, like I said, it is a technical method to estimate the total area underneath the graph while we depend on the right endpoints of the subintervals. So right now we have three subintervals, 0 to 3, 3 to 8, 8 to 9. And we're just going to depend on the right side or right endpoint of that subinterval, which will be 3, 8, 9. So the graph will look like, while 0 is 2, it goes right here because we're going to depend only on the right side. Like this. So this will be the right Riemann sum method. So let's calculate the total area depending on the right side. The base is 3 because 3 minus 0. What is 8 minus 3? It is 5. I'll circle the base numbers. What is 9 minus 8? It is 1. So, because we're just getting the three different area of the rectangles and sum it up, what is the height of the first? It is 6. So it will be 3 times 6 plus 5, we got the base 5, and depending on the right, 9. 5 times 9 plus base is 1, height is 10. 1 times 10. This will become 18, I'll write it bigger. 18 plus 45 plus 10, which will become 73. So, this is the area of right Riemann sum. Then let's try left Riemann sum. So obviously, for left Riemann sum, we're going to only depend on the left endpoints of the subintervals, while there are 3 subintervals. So, like as before, this will be 0. I'm just plotting the point right now. Looks a little different. So, left Riemann sum, let's depend on the left side. Like that. As you see, even the graph is going up, I'm only depending on the left side, not the right side. So this will be our rectangle, 3 different rectangles. So let's calculate. What's the base? As before, it'll be 3, 5, and 1. Then what's the height? Because it's left Riemann sum, we're depending on the left side, so height will be different. This will be 2. So I'll write down 3 times 2 because it's equals to 2 plus 5 times 6 because we're depending on the left plus 1 times 9. Now let's calculate. So 6 plus 30 plus 9 equals to 45. As you can see, these numbers are different because we use the different numbers with the subintervals. So, in the basic concept of Riemann sum, if the graph is increasing, if you use right Riemann sum, it will be overestimated like this. And if you use left Riemann sum while the graph is increasing, it will be underestimated. As you can see, these underestimated areas and these overestimated areas like that. So, however, like vice versa, obviously, if the graph is decreasing, if you use the right Riemann sum, then it will be underestimated. If you use left Riemann sum while graph is decreasing, it will be overestimated. So, what is the easy trick? If you graph everything and do this in AP calculus test, you will not have enough time to do it. So, I will just show you the first easy trick of right Riemann sum. Like I said, remember the concept of only using right side of the subintervals. So, when you get this chart without these graphs in real calculus test, there will be no graph like this. So, by looking at the chart, you first have to think how many intervals are there. The way to get the number of intervals, sometimes it can be given. However, to get the intervals is look at the between numbers. So, between 0 and 3, 1 interval, 3 and 8, 2 intervals, 8 and 9, 3 intervals. Like that. Just think this line is a subinterval for the graph. This line. Like I said, 0 and 3, 0 and 3, 1 interval. 3 and 8, 3 and 8, 1 interval. 8 and 9, 8 and 9, another interval. And now, everything's done. So, before you make a mistake, write it down. Base, we're making a rectangle right now. Base is 3 minus 0, which is 3. And another base, so this is first base. Second base will be 3 minus 8, 5. Third base is 9 minus 8, 1. Like this, 3, 5, 1. 3, 5, 1, we're making the base of the rectangle. Now, how do we get the height of the rectangle? Because it's right Riemann sum, only think about the right. 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 So, ignore left, because if we use 2, that means we're using left Riemann sum because we're depending on the left. However, because it is right Riemann sum, like I said, we're only focusing on the right sides. So, height will be, this is height, will be 6, 9, 10. And if we calculate this, 3 times 6, as we did, 18, plus 5 times 9, 45, plus 10, which will become 73. Isn't this way easier? So another advantage of using this is sometimes the graph will be increasing and decreasing like that. And if you use this, it'll be a little confused for you. It'll be a little confusing. So by looking at this, ignoring all the graphs, how it looks like, just look at the graph. Ignore the left one and just think about the right side. And before you make mistake, focus on the base. So you have to think the between line as the subintervals and say base of this line is 3 minus 0, base of this line is 8 minus 3, base of this line is 9 minus 8 to calculate it. In a vice versa situation, if they're talking about the left Riemann sums, then you just have to think, oh, let me focus on the left and ignore this part because if we use this, that means we're using right Riemann sums, so we're going to use only these 3 values for left Riemann sums. Thank you for watching and